So welcome to chapter 7. First thing we'll be doing is studying absolute value. So take a moment to read the focus on here. I guess we'll take a moment to read it. So we're going to focus on determining the absolute values of numbers and expressions, so with variables. Explaining how the distance between 2 points on a number line can be expressed in terms of absolute value. So absolute value basically represents a distance. Focus on comparing and ordering the absolute values of real numbers. Okay. Oops. This is for you to do on your own. So this is an investigate. Alright, so pause the video, stop it, whatever. And I want you to go through these questions and just follow the instructions. Try to answer the questions as best you can until you get to the end. Alright, so this one. For real number a, the absolute value is written as that. An a with vertical hashes around it. And it's always a positive number. 2 vertical bars around a number or expression are used to represent the absolute value of that number or expression, which again represents basically the distance, which is always positive. The absolute value of a positive number is just the positive of that number. So the absolute value of positive 7 is 7. The absolute value of 0 is 0, because it represents a distance from one point to another. Okay? The absolute value of a negative number is the negative of that negative number, resulting in the positive value of that number. Okay, it's kind of confusing, but the absolute value of negative 7 is the negative of that original negative 7. So here, a equals negative 7. So what we're doing is we're going negative a, which is the negative of negative 7, which of course results in positive 7. So in general, the absolute value of a real number a is defined as this. The absolute value of a is a as long as a is greater than or equal to 0, so a is a positive number. If a is a negative number, then the absolute value of a is negative a. Because if a is negative, then only this negative will turn that negative number into a positive number. So that's only if a is less than or equal to 0. Your turn. Evaluate the following. So go ahead and hit pause. I'll sketch out the answers here for you, and then you can unpause it when you're done and see how you did. Should take you about, 3.5 hours or so. So A, absolute value of 9 is 9. B, the absolute value of negative 12 is the negative of negative 12, which is 12. This seems like it's not necessary right now, but it becomes necessary later when we start using variables. So we are going to get into the habit of writing it like that. So write the real numbers in order from least to greatest. This is just an exercise that you can easily do on your own. You know that anything with absolute value hashes around it is going to be positive. So pick your greatest negative values. They'll go first. Everything else will be positive. And you can figure it out. I have faith in you. This one, evaluate the following. So we just follow our BEDMAS ruling here. So brackets, absolute value brackets count as brackets. So we do those first and then we do the subtraction. So the negative of negative 4 minus the negative of negative 3. So this becomes 4 minus 3, and your answer is 1. Now this one, we do what's inside the brackets first and then take the absolute value. So negative 12 plus 8 is negative 4. And we take the absolute value of that, so we write it as the negative of negative 4, and that becomes positive 4. Again, evaluate what's inside first. So the absolute value of negative 36 plus 5 squared is 25. Now I know this says exponents before multiplication, but since they don't interfere with each other at all, you can do them both at the same time. And then you can do the addition afterwards. Negative 36 plus 25 is negative 11. And then you can drop the hashes and write it as the negative of negative 11. And of course that is 11. Okay, so this one, Wesley volunteers at a local hospital. What a good guy. He's interested in a career in healthcare. So he takes the elevator from the first floor up to the 6th floor. So we have to find the difference between these two floors. So he goes from 1 to 6. Of course, it's a distance, so we're going to take the absolute value of it. His list of tasks for that day sends him down to the 2nd floor. So he goes from the 6th floor down to the 2nd floor now. So we're going to add that to his distance traveled in the elevator. He goes from 6 down to 2 for a change of 4 floors. Then he goes up to the 4th floor from there. So he goes from 2 up to 4. And then he goes down to the 1st floor to greet visitors and patients for the day. So from the 4th down to the 1st. What is the total change in floors for Wesley that day? So here he had a change in floors of 5. Here he had a change in floors of 4. Change in floors of 2. And a change in floors of 3. So the negative of negative 5 plus 4 plus the negative of negative 2 plus 3. And this is 5 plus 4 plus 2 plus 3. So this is 5. 5 and 5 is 10, and 4 equals a change of floors of 14 for that day. That's all for today's lesson. Get some practice from the textbook, and I will see you in class.